Hello everyone, my name is Xiao from Indiana University, Bloomington. My advisors are Xiaojing, Liao, and Luyi, Xing. Today I'm going to present my paper, Lalaine, Measuring and Characterizing Non-Compliance of Apple Privacy Labels. Looking around, you will see our lives are deeply intertwined with mobile applications. Every interaction, every tap may allow a flood of personal information leak from the device. As the mobile ecosystem becomes more complex and the privacy risk increase, there is a growing emphasis on privacy laws around the world. For example, the GDPR in European and the CCPA in US have been established to safeguard the user data. Those regulations mandate the company to transparently disclose what data they collect and how they're going to share and use the user data in their privacy policy. However, have you ever tried to read one privacy policy from the start to the end? The unfortunate reality is many of us just click "I agree" without understanding what we are agreeing to. To address this, the leading companies like Apple and Google have taken a significant step to bolster user privacy, which is the launch of privacy label with the goal to amplify the transparency and enhance the data protection. Let's take a deep look at the privacy label defined by the Apple. Similar as the nutrition label on the food, privacy label is designed to list the data collection practice of an app. It brings much needed transparency by using a semantic four-layer taxonomy. So the first layer is data linkage. It tells user whether the data is tracked to you, whether the data is linked or not linked to you, or whether the data is collected or not collected. Under each category, Apple also defined 6 data purposes, like third-party advertising, analytics, etc. Those data purposes will help the user understand why the app is collecting my data. Further, the Apple also defined 14 data categories and 32 data types. As we can see, such succinct and well-formatted privacy label will make it much easier for the users to understand what data is collected and how the data is going to be used. Before dive into our paper, let's take a look at the literature of the privacy label. Back in 2009, the idea of a privacy nutrition label has already proposed by the scholar. Since then, there are tons of the work on the design of the clear privacy label for the websites, for the app, for the IoT device. Scholars also perform the user studies to understand the challenge of creating a privacy label from the developer perspective. To solve those challenges, efforts have also been made to develop the tools to assist the developer in formulating accurate and effective privacy labels. Recent research also trying to evaluate the evolving landscape of the privacy labels by measuring how quickly the app developer create and update their privacy label. There is our work force in this research direction, which is privacy compliance analysis for privacy label and mobile apps, which aims to analyzing any inconsistency between the privacy disclosure in the privacy label and the data collection practice from the code label. So different from previous work, our work is the first to perform the large-scale and comprehensive study for the privacy label compliance. Specifically, we defined 3 types of data flow to privacy label inconsistency with formal definition. We developed an end-to-end tool to automatically assess those inconsistencies. We also uncovered the root cause of non-compliance app and performed some case studies. From the high level, our methodology is to extract the data purpose pair from the code behavior and then compile them with its privacy label to output any inconsistencies. To achieve this, we first downloaded the app binary and also simultaneously collect the privacy label of this app. And then our pipeline will automatically install this app on a jailbroken iPhone. And then we will utilize App UI Monkey to automatically trigger the action to execute the app. And at the same time, we will hook the sensitive API and record the network traffic to get the return data, call trace information from the hook system API information, and we also record the network traffic of the app. In order to predict the actual purpose of what the data that being collected, we build a machine learning model by extracting the features from the call trace information and network traffic information to perform the inference of the purpose. After we get the data purpose pair from the dynamic code behavior, and we also get the data purpose from the privacy label, then we will put them together into the consistent model. And here we define 3 types of inconsistency. The first type is neglect disclosure, which means the data is actually collected in the code behavior, while this data is not disclosed in their privacy label. And the second is contrary disclosure. This is defined at the purpose level, where, for example, from the code behavior, if we observe the data purpose is analytics, but in its privacy label, it claimed it as app functionality, we will regard this as a contrary disclosure for the purpose. And the third one is inadequate disclosure. This inconsistency indicates that the app developer only partially correctly specify all the data usage, but however, it didn't specify all the data usage. For example, if we observed three purposes associated with this data, but in their privacy label, they only disclose 1 or 2, we will regard that it missing disclose one type of the purpose. Finally, if we detect any inconsistency from the consistent model, we will regard this app as a non-compliant app. This is our result. By running on more than 5,000 iOS apps, we have detected more than 3,000 privacy non-compliance. As we can see, the neglect disclosure, which is the most severe case, occupies a staggering over 16% of iOS apps, and followed by the contrary disclosure and the inadequate disclosure, which indicated that at the most case, the developer just completely ignored the disclosure of the collected data. Let's dive deeper into the root cause of the inconsistent app privacy label. The first one is misleading third-party disclosure guidelines. To help the app developer fill out the privacy label correctly, some third-party SDKs released the guidelines about what privacy label items they collect or not collect. Ideally, such guidance provided the transparency of their data collection practice should able to help the app developer to generate a privacy label correctly and comprehensively. However, we found that those guidelines are usually incomplete or even incorrect, which can easily lead to the non-compliance for the app. Here is an example. We observed that there is an analytics SDK collect precise location data by invoke the system API. However, as we can see, it also sends those user data, location data to its own server. However, in its privacy label guidelines, it didn't suggest the app developer to fill out the privacy label to declare that the collection of user location data. And the second is non-compliant and dishonest app makers. Many app owners will dedicate the app development to the app makers. However, the data collection practice of app makers are opaque to the app owner who are responsible to fill in the privacy label. In such scenario, app makers can be dishonest and stealthily collect the user data and send it to its own server. And in our study, we have found 9 app makers that distribute more than 100 non-compliance apps. For other root cause, please see the detail in our paper. And here are some takeaways. And the first is that, as we can see, the privacy label non-compliance in iOS app are prevalent with a serious impact on the user privacy. And the root cause of the privacy label non-compliance are diverse, including the misleading privacy label guidelines, dishonest app makers, etc. And we have reported all our findings to the Apple. But unfortunately, several weeks ago, we received the response from them said that they are still under investigation of those huge inconsistent apps. And also, we released the end-to-end tool to automatically assess the flow-to-label inconsistency. And we also provide some recommendations for the stakeholders to help them to better achieve their privacy and accountability goals. For example, for the Apple, they should provide a comprehensively ontology of the sensitive data and the sensitive API. And for the SDK vendors, they should improve the data transparency by improving the accuracy of their privacy label guidelines for the app developer. And for the app developer, they should scrutinize the SDK integrated in their app to better understand their data practice. And that's all. Thanks for listening to my talk, and any questions?